This is 2.2.3, and we're going to really put our focus on area and perimeter. So our goal today will continue to develop an understanding of area and begin to look at how this affects that perimeter, and we're going to be focusing it around base 10 blocks today. Base 10 blocks, all right? So we've learned a lot about area, the number of square units that are needed to cover the shape completely without gaps or overlaps. That has to do with tiles, right? And perimeter, the sum of the lengths of the sides of the shape. That one, what we call toothpicks. If a shape has a particular area, will its perimeter be the same as any other shape with the same area? If you change the area of a shape, does the perimeter change? So today we'll use base 10 blocks to investigate the relationship between area and perimeter. I know you can't click on this in the video, but I'm going to have that link in the resource page, the at-home learning resource page. So if you ever want to use base 10 blocks at home, you can use that link to create that, and it will look like, not that. That's funny. It'll be this. You will open up this, and you can pull these blocks out, and you can play with them. If you double tap, they spin. Obviously, you wouldn't need to double tap that, but then you can move these if you want, and you can take as many as you need to. Okay. All right. Let me just reload this page here. Let's go back to where we were at. All right. So, your teacher will give your team, a set of base 10 blocks. For the purpose of this lesson, only the top face of the base 10 blocks will be considered as part of the shape. Be sure to use the blocks in a way that all team members can touch them. So we're going to use those in class. If you're at home, you'll have that digital option. So there's 3 kinds of blocks. Find one of each kind of block and trace it on your paper. Okay, so you actually did just see those blocks there. And so what I'd like you to do is just trace those 3 onto your paper, right? We had, actually, I'll just go right back to it. We had this one. Trace those. You could trace those lines in there. Might be helpful just to see and understand. You won't have to do that all the time, but maybe in this case it could be helpful. So trace those 3 on there and then come back. All right, now that you've traced them, and I know you've traced them probably, I know you didn't exactly trace them if you're using a digital version or whatever, right? But now that we have them on there, we're going to go to B. The side length of the smallest block is 1 centimeter. Okay, so if we look at this, I probably could have labeled this, right? Centimeter, 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 and centimeter. On your paper, mark the lengths of the sides of all 3 blocks. So I marked that one real quick. Now if we come down, we notice that this one's also going to be 1 centimeter. And because when you do that, when you've drawn that on here, you would have had 10, right? 1, 2, 3, 4, 5, 1, 2. So I think that should be 10. So then we would label that top one 10 centimeters, right? That's going to be 10 centimeters. And then when we go to this one, this will have all of those same lines in there. And what we can do is we can label this one a 10 centimeter by 10 centimeter. And I could label all the sides like I should have done in the previous one, right? There. So now we have labeled all 3 sides lengths on there. So now we're asked in C to find the area and perimeter of each of these 3 blocks. Notice that I did label them with the numeric value, and I probably should have labeled them with these correct one. I apologize. So now when we talk about area is going to be our length times our width. Length times our width. So in this case, it's going to be 1 times 1 to give us 1 what? 1 square centimeter. Okay, 1 square centimeter. All right. That's kind of what we've been working on, is those with rectangles, is base times height, or length times width, those sorts of things. When we're doing the perimeter here, the perimeter is, again, adding up all of those sides, so that's going to be 1 plus 1 plus 1 plus 1 equals 4 centimeters. Again, I cannot emphasize enough the importance of making sure that we are using the correct units now, okay? All right, let's look at this one. The area in this case is the length times that width. So the length is 10, the width is 1, and we get an area of 10 what? Square centimeters. And I'm just putting that on there to show you the two different ways that we could write the area, right? Notice the two. I have, let me do that. I have 1 square centimeter and 1 square centimeter. Notice the square is to the right of the centimeter, okay? All right, so back here to perimeter. Perimeter, again, is adding up all those sides. 1 plus 10 plus 1 plus 10, right? That's going to be 22 centimeters because that's a length, not an area, right? Where we're talking about those individual squares, okay? And last but not least, we have a much probably larger than what I drew here, but I did need to fit it onto the paper, my area and perimeter of my square here. And that one is a 10 centimeter by 10 centimeter. So to find the area, we would do that length times that width to get 100 square centimeters. And that perimeter is going to be 10 plus 10 plus 10 plus 10. And yes, you could do 4 times 10 to find that. That's fine with me. And we would have 40 centimeters. Okay, make sure you mark yours and mark yours correctly. All right, let's move to D. What is the combined area of the blocks shown at the right? All right, so what we have in this case is we have all these different blocks. And so what we need to do is we're looking for combined area. So if I were to look at the combined or the area or whatever, for example, if I just look at this one, what's the area of that? Well, if I go back up here, my area was, when I look in the far right here, 100 square centimeters. So when I mark that, I'm just going to use colors to help me coordinate this. So this is an area of 100, right? Then what I'm going to do is I'm going to add the other parts to this, okay? Let's choose another color here. Let's do a green. So the green here, in this case, we're going to use for those long ones. We're getting the name of them right there, right? 2 and then 3 of them, right? And the area of each of those is 10. So I probably could have labeled that right here. So that's going to be 30 square centimeters, right? And then I need to add each of those little pieces down below. And let me change my colors quick. All right, so each of those are 1 square centimeter, and I have 1, 2, 3, 4, 5 of those. So I would label that 5. So I have 100 plus 30 plus 5, and my final answer will have 135 what? Square centimeters. Okay, again, the 2 goes after the cm. All right, that wasn't too bad. All right, the blocks are named by their area, and I think I've probably been even saying that. So the block that has an area of 100 square centimeters is called a 100 block. The block that is 1 square centimeter is called the 1 block. Which blocks would be used to represent an area of 127 square centimeters? With your team, find at least 2 ways to build that 127. All right, let me go back to this. I'm going to reload this. So I need 127. Well, let's get this block out because that will represent my 100. Then I could take, sorry about that. I don't know what's happening here. I can't get out. Reload. 100. And there's my 20, right? And then here's my 7. 1, 2, 3, 4, 5, 6, 7. All right. Now it's asking you to try another way. So that's one way you could just draw that on your paper, right? It's asking you to come up with another way. Well, there's multiple ways for you to do that. You might not be seeing how to do that right now. But if I take and instead of doing a 100 block, what could I do to represent that 100 block without using the 100 block? Well, I could represent 10 of these, right? 1, 2, 3, come on, 4, 5, 6, come on, 7, 8, 9, 10. That's one way to do that. Plus, I still need that, so that's my 100. I still need to represent the 20, right? So 1, 2 to represent those. I'll put them together here just so that you see that they're combined. That's those together, right? That's the same. And then I could use that, right? I could get my other 7 out here. 1, 2, 3, 4, 5, 6, and 7. So there's one way to do that. You could do it another way. You could break the 10 down into 10 individual pieces, couldn't you? Okay. I want you to go ahead and copy those down for this. Okay. Now, we're going to find all the ways you can represent an area of 34. I'm going to let you do that. Kind of already led into that through the 127. The most obvious way is to do 3 tens. So something like this, right? 1, 2, 3. And then I could do 4. 1, 2, 3, 4. That's one way to do that. But there are other ways to do it, right? How could I represent that 30? I could represent it as 10 ones. I'm sorry, not that 30, that 10. How could I represent this 10? Also as 10 ones. And how could I represent this? Also as 10 ones. So I could really put 34 individual 1 blocks to do that. Okay? All right, be ready. No explanation to the class in this one. All right, so now let's move into arranging a 100 block and a 1 block as shown to the right. What is the area of J's shape? What's the perimeter? So if I go here, right, if we're going to look at his block is a 100, right, and a what? A 1. So we have, let me go ahead and write those, right, put that in there correctly. That is the 100, right, plus 1 to give me a total area of 101 square centimeters, right? All right, now that second picture is for part B, by the way. And let's do the perimeter. All right, let me zoom in here. Let's focus on our perimeter here. So I have to go back and think. I guess I could come back up here and for us to look at it, right? I need to realize that each side is 1. Each of these is 1 and 10, right? And then each of those are 10, right? So let's go back here. All right, let's put our attention on that one. Let's choose a different color here for this. Let's do an orange. So if I'm looking at the top is going to be 10 centimeters, right? This one is 10 centimeters. This one is 10 centimeters, right? Just that bottom piece. Now I got to do a little zooming right here. I have a 1 centimeter here, 1 centimeter here, and right there I have 1 centimeter. Okay, I do not count those right in the middle that are touching each other because they're not part of our perimeter. They're not part of the outside. So the next thing that we're looking at is what is the distance from, I'm going to highlight it quick, the distance from there to there. The first thing you might want to say is 10, right? The problem is that it is not 10. Why? Because I have this block covering up one of those 10, right? Let me go back and let's go to this right here. Let me reload that page. Let me put it out there. There's my 1, I'm sorry, my 100, and there it is right there, right? Now when we look at this, I can't Actually, I'm just going to screenshot that. When I, so when I go in here, and we're going to edit this, sorry about that, taking too much time. The focus should be, if you notice here, I have one, another one, another one, another one. And when we add up all these pieces, right, that whole thing becomes 9. Then I have my one here, one here, one here, right? So make sure that we understand that once we have one block on there, we have now made that a 9. This one's a 10, a 10, and a 10, okay? All right, let me go back to our lesson here. So this piece right here is 9. Now we can add up all those pieces. 10 plus 10 plus 10 plus 9 plus, I'm going to just put those together, 3, right? That's going to be 42, I think, centimeters, okay? We're going to do the same thing. Now this time I'm going to go a lot quicker. The reason I'm going to go a lot quicker is because we had a much further discussion about this in the last one there. So when we talk area, area is going to be the 100 plus 1 and 1. So that's 100 plus 2 of those blocks. That's going to be 102 square centimeters. And then let's talk perimeter. Perimeter in this case is 10 centimeters, 10, 10, 1, 1, 1, and then we're going to zoom in a little bit. That part is 1, and now up here, this one is not 10, it's not 9 anymore, but it is 8, right? All right, now let's put all those together. We have 10 plus 10 plus 10 plus 8 plus, I'm going to group all of those other ones together, 4, right? 1, 2, 3, 4, and that gives me 42 centimeters. Did the area of a shape change? Yes, it did. Did the perimeter change? No, it didn't. Interesting. What if Jay added his new 1 block to a different part of the 100 block? Would it change the perimeter? I'm going to have you do that. I'm going to let you try that. Oops, I want to go back to here. What if he added a, so now we're going to go to this. What if he put it somewhere else? Maybe here, or here, or here, or here. I want you to just play around with that once, or maybe even on the end of that, right? Let's try that. You try it, you play around, and you answer that question, okay? You should be able to kind of answer that as you just check it yourself. But the answer would be, does it change the perimeter? It will be a yes. I just want you to see that in when you play around with it. What have you discovered in parts A through C? That is, what can happen to the perimeter when the area of a shape is changed? Well, the key part to this one, and I'm not going to write it all, but to summarize this is, when you change the area, the perimeter doesn't always change. Sometimes it changes, sometimes it doesn't. And that's the real key part. And you know what? It is so important, I'll write it. When you change the area, the perimeter will change some of the time. Not always, okay? All right, now, last thing is find the area of each figure below in at least 2 ways, okay? Explain how you got the answer. So what I did is I just created the 2 figures so that I could just show how I found that area right away. One way to do that let's do this one right here, okay? One thing that's really helpful is to know and understand all of these different sides in here, okay? So since this is 5, then we know that that's 5 inches, right? And since this one is 5, we'll know that that's 5 inches. But boy, how do we get this last one right here, right? How do I get that last one to get to whatever we need, right? So I'm going to erase that because we'll get there, okay? So what I need to do is I recognize something here. Let's do this. Let me choose this blue pencil. All right, I've just created the bigger rectangle that was once there. If this is 4, then this one becomes 4 inches. But notice that the whole thing right? This whole thing right here is from here to here, right? It is 13 inches. Well, if that part is 4 and this part's 5, how much remains, right? Well, the 5 plus 4 is 9 inches. So how much is left over after that? And then a 13, that would be 4. So this piece down here will be 4 inches. Now you might have thought, oh, it looks about the same as this 4 inches, so it's got to be 4 inches. You don't always know that. You can't just guess that that's going to be the case, okay? All right, I'm going to quickly get rid of this clutter that we've got on here. And now that I know all these sides, what I'm going to do is now I can just finish this. Now when I'm looking at this, one way to do this is to break this down into smaller pieces, smaller rectangles. So I'll break it down like this. I'm looking at this bottom rectangle, and what I notice is I see that it's 13 by 5. 13 by 5. So what I'm going to do is I'm going to multiply those two sides, 13 times 5, to get the square inches of this bottom rectangle. Okay, that's this whole thing down here, right? That's that whole thing right here, and I'm leaving white space to write on. Okay, and 13 times 5 will be 5. We'll carry that 1, and that will be 65. 65 what? Square inches. Okay, so now I need to do that top one. Right, I'm going to do the top one. Let me choose a different color. Let's choose green and green. So what I'm doing again is I'm looking for the area of that piece right there, right? And so I'm going to kind of clear out a spot in the middle for me to find the area of that, right? And I find that the I'm going to need that as a 5 by 5. So I could just do that multiplication, but that's going to be 5 times 5 to give me what? 25 square inches, right? Inches squared. There we go. Now, when we do that, I said use different, it shows up here, right? Use different colors to show that you didn't have to. It's nice too. But what we're going to do now is we are going to combine those two pieces to find the area, okay? So I have 65 plus 25 to give me what? My total, right? My total. So I have 80. Is that right? No, it's not 80. That's 90, isn't it? Sorry about that. That is 90. Sorry. There we go. 90 what? 90 square inches. Okay. So this next one will go a whole lot quicker for us to do this. All right. So when we do this next one over here, I could look at that since I already know this is 5, this is 4, and this is 5. We can just break this down. In this case, how about we break it down to 3 pieces? Right here and right here. Okay, and I'm going to be much quicker about this one. This piece right over here is 5 times 4 on the left, so that's 20 square inches. On the far right, I also have 20 square inches. And now this rectangle in the middle is 5 by what? This whole length is 10. How did I figure that out? Because this piece is 5 and this piece is 5, so the whole length is 10. So the inside is 50 square inches. Again, I've been writing both square inches in different ways so that you see that consistently. All right. 50 plus 20. What happened? Oh, it's not writing here. Here we go. Plus 20. Plus 20 is 90 square inches. Now let's just say for a second I kept that one as an 8. I would have done it this way and I would have noticed it's different answer, and then I would have been like, what's wrong? And that's when I would have caught my mistake that I just simply added incorrectly. But we got it now, don't we? All right, we're going to do this one down here. All right, let's find the other pieces real quick. All right, so since this whole length right here is 6, this piece is 2, and that piece is 2, we're looking for that one right there, right? Again, if I were to extend this like this, I find that this piece is 2 inches, but the whole thing is 6, so this must be 2 inches. That makes that middle piece right here 2 inches. Okay, again, I went quickly through that, but I'm going quickly through that because we've started to kind of talk about or break some of that down, right? Now that bottom one, oh, that's kind of a tricky little one, isn't it? How could I get that one? Now this one works a little bit different. Since this is 3, then this is 3 inches. But that whole top part is 5, so that must be 2 inches. Oh, let me extend this. That means that 2 is this 2 inches. So now I'm looking at that rectangle down in the lower right. Since the whole thing is 8 and that's 2 inches, this must be 6 inches, right? Well, if that's 6 inches, then this piece is 6 inches, okay? All right, now I know that went quick. You can rewatch that video if you need to. I'm going to get rid of all this extra stuff we don't need right here. And you know what I'm going to do? I'm going to mark those right away on this one over here. So that's 2 inches. This is 6 inches. And this is, whoops, I don't need that bottom, 6 inches. All right. All right, here we go. Break it down into pieces. Let's do this. Since that piece right there, that's a 3 by 2. That's going to be 6 square inches. This one goes all the way down. It is a 6 by, what's its length? It's not 5 and it's not 8. Remember I did erase that part, but it was 2 square inches. Or not 2 square inches, 2 inches. So this becomes 12 square inches. And then down in the lower right there, I have a 6 by 2, not 8, because 8 is the full length. And that's going to be 12 square inches. We're going to put all those pieces together. 12 plus 6 is 24 and 6, 30 square inches. All right, now if I did that wrong, I would find out in this next one, won't I? All right, let's zoom into this. Let's do it differently. Let's break that down that way. And let's break it down this way. How about that? The top piece is a 2 by 5, so that's going to be 10 square inches. That middle one's tricky, so I'm going to pause on that one. I'll go to the bottom. The bottom has a length of 8 and a width of 2. That's 16 square inches here. And then that middle one right there, I know it's 2. And what was this one again? Do you recall? That one was 2 inches too. So this one is 4 square inches, right? So let's put all those pieces together. 10 plus, ooh, that's square inches up top. Nearly forgot. 10 plus 4 plus 16. 16 plus 4 is 20. 20 plus 10 leaves me with 30 square inches, right? 30 square inches. It's the same answer. Great. All right. I think you should take a second. You could pause the video and read this. I think it's a good reminder that area of a rectangle is length times width, which we've been just practicing. So like, for example, 6 times 3 is 18. Down here, this is just bonus. If you want to try to play with those base 10 blocks and see if you can't get them to 110, 107, and 144, those should be squared, like as in up here, I just noticed. So you can try that, all right? Let's go back to the top. Our goal was for students to continue to develop their understanding of area. We did that by multiplying length times width and beginning to look at how this affects perimeter, which we played around with using base 10 blocks. I felt like we were pretty successful there today. Let me know if you have any other questions.